correct order of ionic radii of O2 minus, N3 minus, F minus, Mg2 plus, Na plus and Al plus 3 is, okay. So are these species isoelectronic? First let us check that. So O2 minus will have how many electrons? O2 minus will have 10 electrons. N3 minus will also have 10 electrons, okay. F minus 10 electrons. Mg2 plus will also have 10 electrons. Na plus 10 electrons. So all of them have 10 electrons, guys. So they are isoelectronic. So if we are talking about isoelectronic species, the ionic radii will be inversely proportional to what? Will be inversely proportional to the effective nuclear charge, right? And if I know correctly, then the effective nuclear charge will be maximum for what? Will be maximum for Al plus 3. So Z effective will be maximum for Al plus 3, right? So if it is maximum for Al plus 3, Al plus 3 should have what? Should have the smallest ionic radii. So in any of the options, do I have Al plus 3 with the smallest ionic radii? Let us check. Yes, in option 1 and option 2, okay. So Al plus 3 has the smallest ionic radii. So what will be the maximum ionic radii, guys? Which element will have the maximum ionic radii? Let's see. Out of all the ions which are given, which ion will have the least effective nuclear charge? Nitrogen, guys. Nitrogen will have the least effective nuclear charge. It has got only 7 protons, guys, okay. So Al plus 3 is maximum and N3 minus is minimum. So N3 minus should have what? Should have the least effective nuclear charge. So N3 minus should have the biggest ionic radii, okay. So again 1 and 2 both. So if 1 and 2 both again, then we'll have to look at what? Then we'll have to look at the second last element. So after nitrogen, what we have? After nitrogen we have oxygen. Yes. So if we are looking at oxygen, the effective nuclear charge of oxygen will be in the order of what? We will have O2 minus over here. Yes. Therefore the answer is what? Therefore the answer is option 1, guys, okay. So basically what you have to remember over here is ionic radii is inversely proportional to effective nuclear charge, okay. Aluminium has maximum effective nuclear charge, so aluminium has the smallest ionic radii, okay. And then after aluminium we'll have magnesium ion, then sodium ion, fluoride ion, O2 minus ion and N3 minus ion, okay. Is that clear? Let us move on to the 5th question, guys. Adsorption of a gas follows Freundlich adsorption isotherm, okay. If X is the mass of the gas adsorbed on mass M of the adsorbent, the correct plot of X by M versus P is, okay. So let us look at the options, guys. Okay, so what we have is we have a straight line over here. So the first option is out of question because we have a graph for X by M is equal to K dot P raised to 1 by N. So it will always be a curve, guys. It will be a curve, right? So option 2, let us check option 2, what we have. So at low temperature it is high. The extent of adsorption is high, and at high temperature the extent of adsorption is low. Is adsorption a exothermic process? Yes, it is. So it will be favored at what? It will be favored at low temperatures. That's why the extent of adsorption will be high at low temperature and low at high temperatures. So the answer over here is option 2, guys, okay. Because if I look at option 3 and 4, this is again a straight line. Option 4 is a straight line, so this is not applicable. And here at high temperature the extent of adsorption is more, which is against whatever we have just said. That's why option 3 is also not correct. So the answer is option 2, guys. Okay, so very simple question based on what? Based on adsorption. Next question. Question number 6. The correct statement about probability density except at infinite distance from nucleus is, okay, so it's a question from atomic structure, guys, and it is talking about probability density. Okay, so if you are well aware of the concept of nodes, you will be able to answer this question. It can never be 0 for 2s. Okay, it can be 0 for 3p orbitals. It can be 0 for 1s. It can be negative for 2p. We have to identify the correct statement, guys. Remember this, we have to identify the correct statement. Okay, so which is the correct statement out of all? It can never be 0 for 2s. It can be 0 for 2s, guys. Okay, it can be 0 for 3p. Yes, guys, it can be 0 for 3p. So the answer is option 2, guys. Okay, is that clear, guys? Because in 3p you have one radial node, right? That's why the answer is option 2. Let us move on to the 7th question, guys. Okay, a question from coordination chemistry based on isomerization. Let's see. Consider the complex ion trans COEN twice. En stands for ethylene diamine, Cl2 plus, okay, COEN twice, Cl2, and the overall charge is plus. Okay, the correct statement regarding them is both A and B can be optically active. Both A and B cannot be optically active. A cannot be optically active, but B can be optically active. A can be optically active, but B cannot be optically active. Okay, so it sounds very tricky, you know, when you read all the options, it sounds very tricky. So the best thing is you draw the structure and see. Okay, so when we draw the structure, so first one is trans, right? So we have CO, it's an octahedral complex, right? So this is our ethylene diamine. We are first dealing with the trans one. So this is ethylene diamine connected to Cl and Cl. So this is carrying a positive charge. Now if you look at this structure, guys, this looks like a perfect symmetrical structure, right? It will have a point of symmetry. Ethylene diamine will be in one plane, chlorine will be above the plane and below the plane, right? So it will have a point of symmetry, right? That's why this cannot be optically active. So this is optically inactive, guys. This is optically inactive, right? Let us look at the trans structure. So we have CO at the center. We'll have a Cl over here. We have a Cl over here. And then we have NH2. NH2. So in this case, what do we observe? So both the ethylene diamine groups are in different plane. So here you don't have any axis of symmetry, guys. Here we don't have any axis of symmetry. That's why this molecule will be what? This molecule will be optically active, guys, right? So the answer is trans COEN twice Cl2 plus is optically inactive and cis COEN twice Cl2 plus is optically active. Okay, so A cannot be optically active, but B can be optically active. So the correct answer is option 3, guys. Okay, let us move on to question number 8.